So now we will see. Did you do the example? Did you do the example? I'd given an example. X of n. What was that? Given as 1 by 3. 1 by 3 raised to n. Have you solved this? U of n, right? Minus half raised to n. U of minus n minus 1. So did you do this? So finding the DFT and ROC. Find DFT, sorry, what is that? Find the Z transform. So sorry. Find the Z transform and ROC. So let us see who all have tried to attempt this question. So x of z, or you can say the Z transform of x of n, is nothing but zt of x of n. All are supposed to write along with me, right? So how will you do this? Use the definition. What is that definition? N is equal to minus infinity to infinity x of n and z raised to minus n. Now what is my xn here? My xn is, I will have to use a bigger equation in this. With this limits, I have two terms, minus infinity to infinity 1 by 3, right? 1 by 3 raised to n u of n. This is a mixture of the left hand side, we can say indefinite sequence or infinite sequence, and right hand side infinite sequence. My first equation is a infinite right hand sequence. My next equation is the infinite left hand sequence, right? So this is simply, as you note it as, here we forgot to mention z raised to minus n. Don't you do that. Okay, into z raised to minus n. U of minus n minus 1, then you have z raised to minus n. This is your whole equation. What to do? So the term 1 and term 2, we'll have to expand and see. Okay, in this condition, you might be remembering, if a was my right hand side constant, b was my left hand side constant, what was that? My b is going to be always greater than mod b, always greater than mod a, is it not? This I have to take into consideration. If it is there, then only I'll be able to solve, otherwise I'll not be able to solve this. So you just see that b is 1 by 2 and a is 1 by 3. So whether It is possible, yes. 1 by 2 is really greater than, that is 0.5 is greater than 0.33. So this is okay, I can solve this. So the first point I get is, I will change this to my standard equation. It is starting from 0 because u of n is there, changing the negative limits to 0. Then I have my original constant, which will be raised to n into z raised to minus n. Then I have this term, if I remember.
n is equal to 1.
Yes? Yes?
मैम n is equal to 1 आता है ना.
n is equal to minus infinity to, step wise जाऊयात का, minus infinity to,
Okay, okay.
okay, I am very much sure you are doing, but what happens is,
Okay.
let us observe with
Okay,
others
okay.
also. नहीं तो
मैम
suddenly
बाद में वो जो -1 है वो नीचे आएगा ना.
अभी हम लोग और करने वाले हैं ना, विल चेंज
ठीक है,
स्टिल
ठीक
ना,
है.
है ना,
ओके.
विल स्टिल वी आर इन द प्रोसेस. ठीक है, because today we have done the same thing, so we'll just have a, what do you call, a recap. Summation, this whole thing is equal to n is equal to 0. I will use a different ink now. 0, 0, infinity, right? 1 by 3. This is my A. Z inverse, okay, raised to n, raised to n. What is left now? Minus, changing this still is not done because we are trying to stick with our basic steps, baby steps we want to have first, and then we'll move off fast. 1 by 2 raised to, sorry, is it correct? Yes, into z inverse. This whole thing will be raised to what? N. Now I don't want the negative terms. So if you are very fast in doing it, there is no harm in that. You can do it. To this step you can directly come 0 to infinity 1 by 3. I'm finding a bit difficult to write this. Mobile is discharged, so I could not have my webcam on, right? Minus. Now I will change my limits to, the polarities will be changed, that is 0, nahi, it's infinity, na? Infinity to 1, half, then z inverse, then you have minus, and very good. Now again I will change the ink so that you come to know the steps. Okay then, but this is not helping me. This is somewhere I'm not happy. So I will write everything again. What do I do is, I will bring them formula ready. I will make them. My limits will be like this. I have 1 by 3 z inverse. I to take this n. Now if I take infinity to 1 or 1 to infinity, the addition will not change because it is a discrete component. So I will write this as n is equal to 1, 1 to infinity, and I have half. Is it half? Yes, half. You have to make this plus. So it becomes raised to minus 1 and a z. This whole thing is raised to n. Now I am fit to go with the, what do you call? Oh, I will not do that. I will simply cut this much and go into the next page. Okay. So I have this here, right? Who is there on the next left hand side? This is x of z. Okay. So this is x of z. Now which formula do you think I should use? I should use the formula, that is, I will be using both formulas only, then it will be easy for me, is it not? N is equal to 0 to infinity. If I have a r raised to n, this geometric series resultant is equal to 1 by 1 minus r. But under condition, nothing goes free. Sorry, what is that? It is mod r should be less than 1. That is a condition. Another formula which we are again interested is n is equal to, what was that n? 1. Instead of 0, if I am having 1, either I can use the adding ones, going for subtraction 1, or you can go for a direct formula, that is r divided by 1 minus r. And you can use the same condition again here, should be less than 1. That is nothing official about it. Okay. So how about this one? 1 upon 1 minus 1 by 3 z inverse minus, what about this? 1 upon, no 1, what is that? Because it is moving from 1 to infinity, I have to use this as 1 by 2 minus 1 z upon 1 minus half inverse z. This is what I should have. And what are the conditions? Don't forget to write the conditions. 1 by, see, the mod z, what is that? Shall I write it in the, because this is a causal, what should I have? The mod z should be greater than 1 by 3 mod and the anticausal should be less than half mod. This is very, very easy. Means what? But there is again a condition. This is my B, this is my A, is it not? So B is half and A is, so check if 1 by 2, that is the B, is greater than 1 by 3. That means it is possible. So this is B, obviously this is mod AB is greater than A. That I have to check. If it is so, then only we will be going for putting. Now here I am not supposed to, if it is not asked, don't go for the simplification, simply draw the ROC. Or also you can do it, no issue. So this Z will come below. So this is Z upon, what should I get? Z minus 3, Z minus 1 by 3, right? Z 1 by Z you have, okay? Then the Z goes here and the denominator will come in the numerator. And here I have, anybody can tell me, suppose I want to go for, you can say, how to do this? 1 by 2 inverse means I can take it this 2, I can make this 2 z. Let me see if it helping me. 1 minus 2z. Let me see if it helps. Yeah, it will help me. What will happen is z, this will be easier, is it? That's why I've done this. Z minus 1 by 3. 1 by 3.
Hello, ma'am.
Yes.
मॅम समर चिट्टे त्याला प्रॉब्लेम व्हायला मॅम कनेक्ट करायला म्हणतो.
कोणाला?
आत्ता कॉल केलता मॅम समर्थ, त्यांनी कनेक्ट करायला म्हणून होई नाही म्हणा. मी म्हणलो मॅमला सांगतो.
ओके, ठीक आहे. यू कॅन शेअर विथ हिम देन. ठीक आहे. ओके.
मॅम ऑटो ऍडमिट बंद आहे का?
चालू आहे रे, सगळं चालू आहे. आता स्क्रीन
कनेक्ट होई नाही म्हणाला काय? अजून एकदा विचारतो मॅम त्याला.
Is everybody solving with me?
Yes, ma'am.
So minus half. Now check if you are understanding this. This is so easy. Now the things have become very, very easy. See. Are you getting this? Into 2. Right? So 2, this is getting cancelled, this is getting cancelled. So the resultant is, what is the result? The result is z upon z minus 1 by 3. 1 by 3 plus z upon z minus half. Right? So I will again cut this part that I am having and go to the next page. So I have this here, right? Probably I will not be able to remove that. Now what to do? Now I see that I have to find the ROC. ROC. This is to be solved within 1 minute, but because this is our first drawing, so we'll try to do it in a very. So where is B? B is half. What should I do here? B is greater, is it not? So it is half, and this is 1 by 3. Is it not? So I will draw 2 circles through 1 by 3. Oh, sorry. Through 1 by 3. Then through a half, like this. So my RAC, this is half, means it should have the, what you call, the region inside, because it is the
non-causal.
Yeah, very good words. Non-causal signal, it is inside, but I will be finding only that part which is intersecting with the ROC of the causal. Now where is the causal one? Causal says that your ROC is what? Which one? Causal says my ROC is external to this, is it not? I will not be interested in the other part beyond half, is it not? So I will see that this is my ROC Red color is the ROC for the causal signal. ROC for causal. Right? And the blue is, this is the ROC for non-causal. Non-causal. Now this is done. Now the best thing of this equation is, this is x of z, is that first part, it is having 1 0 and 1 pole. Zeros on the numerator, poles on the denominator. 1 0 and 1 pole. So just see now, if I want to draw for the causal, I have the pole which is 1 by 3 and a 0. And for this is the pole. This is the pole and a 0 overlap. Now just see that no, the poles are never in the ROC. Poles, this is a part of the property. Poles never in ROC. Poles are never in the ROC. So this is what you want to say. So when you are having all these things, we can easily understand the properties of the ROC. So what are the different properties? We will go for the, I hope I will change the page now. What is this? It becomes easier for me to type. Let me see. Properties of ROC. What is the first property? ROC is a ring or disk. Disk in the Z plane. Second property is ROC cannot contain the poles. ROC for causal signal is entire Z plane except Z is equal to 0. That already we have seen. Except Z is equal to 0. Then we have one next property. This can be asked as a short note. ROC for non-causal controls except infinity. Now I can't draw this infinity here. I will draw it like this. Infinity. Then ROC for two-sided bracket causal and non-causal together. Two-sided finite. Z and Z equal to infinity. Is it not? Equal to infinity. We can mention that also. ROC for infinite two-sided sequence, just now you have seen, is simply is consisting of what? Of a ring in Z plane, of Z plane bounded by the poles of the two sequence, bounded by the poles of the two sequences. One more thing I think we missed. ROC of LTI system, linear time invariant system, LTI stable system, consists of unit circle. This we will see. ROC of LTI stable system consists of the unit circle that we will see now. ROC, this is a very important point. ROC must be a connected region. That means they should be overlapping. That is what is the meaning of this, is it not? So we saw so many things for now, is it not? How many pages we have done? 5th page, we are having the properties of ROC. One more thing we missed is understanding what is the stability of the system with the help of ROC. What do you mean by stability? What is the relation between the stability? I will use this typer also, it becomes easier for me. Okay. I'll use I want to say that stability and ROC, what is the relation? We'll just see that this becomes very understanding. This is a very important feature. The stability whether a system is stable or not, stability can be stability of a system can be declared, or we can decide, can be decided, we can say, decided using the ROC. This is very, very important. Okay, consider consider a signal, signal which is an impulse, which is an impulse, that is h of n. Okay. Now obviously Z transform is Z of Hn. I will use a square here. Is equal to simply h of Z. Is it not? So if I find this h of Z, it will be very easy to understand. So I will just define the stability. So a LTI system with system function, that is response system function h, hz is balanced input, balanced output if and only if ROC for H contains the unit circle. This is very important. So if you want to check the stability of a system, what you do nothing. You find the ROC of that H of Z and see if the unit circle is there inside the ROC. It should contain the this thing. It's very easy to understand. Let us see if it is clear. Okay, so this is very important. And now we will see really whether it is happening. Let us consider h of n. Let us see this. Okay, h of n. Suppose some h of n is there, which is given as 2 raised to n u of n. What is this? This is h of n, which is given as 2 raised to n and into u of n. So h of z is nothing but, now we are all very much talented to find out the h of z, which will be simply, because this is a causal infinite signal, then it will be simply 1 minus 2 z inverse. I need not have to go for all the calculations. I am very much smart enough to get this. And provided the condition, what is that condition? 2 z inverse mod value should be less than 1. That means this mod z is greater than mod 2. Right? Now look, this is a very important thing you are going to understand. So this is my condition that I have obtained in the ROC. Let me draw the ROC for this best. First I will draw that. Let me see. I'm taking one axis. Okay, what I'll do is I'll use the lines deriving us this. Is it not? So much facility they have given. We'll use this. Right? Now I will do is I will draw my what do you call, number 1. I will take some reference, no? Otherwise how can I draw? So my z is greater than 2. So first I will draw a circle passing through 2. Okay. And where is my ROC? Suppose if this is my square, okay, this is my drawing. I can use the whole universe for the Z, but I will have to make it finite. What is that? This is my ROC. Is it not? Exterior to the 2, because this is a causal. Causal, make it exterior. Causal, ROC is external to your. Now, who is the pole? If you find the pole, you can find it. If you want to find the pole, okay, you can do that. If you want to pole means you have to put it in the, so this becomes Z upon Z minus 2. This is very clear. By doing this, you can easily see this. One pole and 1 0. So this is a 0 and this is the pole. Now, in Z, there is a very important thing. What is that? There is a unit circle, you call it, whose R value is 1. This is a unit circle, where R is equal to 1. You don't know anything, what is the value, but this is a 1. So when the R radius is 1, that circle is called as unit circle. The circle is called as unit circle. Now can you tell me if this is the stable or unstable? Whether this unit circle is in the ROC? Can we say it is not in ROC? Not in ROC. Therefore, the system is unstable because it is not in the ROC. So just see that we have done this very nicely, comparing the different ROC